All right, now for the third segment, as we left off talking about Mount St. Helens and how it's a composite volcano. Nice, picturesque volcano that you would think of with the white snow-capped top. Before 1980, this is what it looks like after 1980. It was an eruption that blew out the side of the volcano. Interesting case study in your book if you get a chance to look at it. Size comparisons. As I said, the Shield volcano, look at how large this thing is. Composite cones, still very high, steep, and then cinder cones are very, very little tiny. And like I said, a lot of times you might have some cinder parasitic cones on this large Shield volcano. So a couple of things as we talked about Pohoihoi and A'a as being associated with quiet type eruptions. You also get these things called Nuea Ardents and Lahars that are associated with explosive eruptions. A Nuea Ardent is basically a pyroclastic flow. It's hot gases, basically means glowing cloud because it's an area of ash that keeps coming down the side of the mountain because it's more dense. It's going to be very hot. You could burn, suffocate, or the blast itself would be enough. So very dangerous things are these Nuea Ardents. You could also get a lahar, which is just a mud flow. We talked about lahars back with mass wasting when we were talking about regular mud flows, but this is a mud flow associated with a volcanic eruption. Obviously, there's a lot of heat, snow cap peak, melts all that snow, and you end up getting these lahars. There's a Nuea Ardent pyroclastic flow coming down the side of Mount St. Helens. And here's a picture of a lahar, which is a mud flow, and it's no different than a regular mud flow other than it's associated with a volcano. Calderas, one of the last things we talked about, it's basically the collapse of the volcano itself. Inside the earth is a magma chamber where all the magma is sitting before it erupts. Eventually, when the volcano erupts, it empties that and leaves a big hole, and the rest of the mountain basically collapses in on itself. That's what a caldera is. Crater Lake in Oregon, say Yellowstone, basically all being a part of a huge caldera. Pipes and necks are associated. They're leftover remnants in the desert southwest that we would see because it's harder rock than the ash that was around it. So it ends up eroding all of the stuff around the volcano around it, and you're left with only the inner part, which was the volcanic neck. The area, as we said, how is that associated? That was one large Pacific plate, and it's the Ring of Fire because it's dotted with a lot of volcanoes because you have subduction. We have an area going under, it's melting, and the magma becomes less dense. It moves towards the surface. It's the end of chapter 9. Any questions, feel free to email. Don't forget to look at all the videos in the full PowerPoint, and we'll see you next week.